Hi everyone, it's been a while. I wanted to make another video concerning the flat earth, and I wanted to show a lot of people the information that's pretty much hidden in plain sight. I wanted to bring up the causes of earthquakes and how it says the radioactive decay generates the heat energy which ultimately powers movements of the Earth's rocky tectonic plates. And the same heat engine that produces earthquakes is the driving force raising the world's great mountain ranges. If this uplift did not take place, the relentless force of erosion would reduce the Earth's landscape to a single flat plane. Now that's where it becomes quite a bit of an issue for the globe model, because the globe model is a ball. Now how can a ball become a single flat plane because of tectonic plates not working? You see, folks, the information is out there and the people just deny it. Now when people get confused with the term level or flat earth, level plane, is the only refute is that how can it be flat because we have hills and slopes and mountains? Well, yeah, we have hills, slopes, and mountains because of, well, tectonic plates. Now, if you look at it again, this doesn't prove that the ball Earth has curvature. All it is that there is uplifting tectonic plates making these hills and slopes and mountain ranges. It does not equal the tectonic plates here, which even in the diagram shows a flat level plane. I mean, just because it has hills and slopes and mountain ranges because of these tectonic plates doesn't mean that it's a ball. And like it says right here, if this uplift did not take place, the relentless force of erosion would reduce the Earth's landscape to a single flat plane. Meaning, if it wasn't for these tectonic plates in the lithosphere, they should just start renaming this stuff to lithoplane. I mean, if it wasn't for the tectonic plates, this level plane here would be a single flat surface, a single flat plane. Now let's look at that again. How can a ball become a single flat plane because of the loss of tectonic plates and earthquakes? It doesn't make any sense. It only makes sense on a flat Earth plane. I mean, that's what it is. People want to get technical on the terminology. Well, there it is. The Earth is a flat level plane where the surface measures flat at every angle. Now, look at this. This is the side view from the inner of the crust, and looking at the water and the mountain ranges. And it's very interesting in what they also say in Brittanica, because this is also from the Encyclopedia Britannica website. You can see that I clicked it from here. I just made it bigger. But it's really interesting what this very well-known scientific information website, you know, people use this for school papers and everything. It's very interesting to see, to hear what they have to say at 57 seconds and to the rest of the video. Listen.
A very large percentage of the Earth's most devastating earthquakes, volcanic eruptions, and mountain-building processes occurs at the boundaries of tectonic plates. Because of plate tectonics, the surface of the Earth is divided into continents and ocean basins, caused by differences in the thickness and composition of the continental and oceanic crust. The continents have a crust that is composed of granite rock, which is lighter and stronger than the basaltic ocean floor. The continental crust is 30 to 40 kilometers thick, while the oceanic crust is only 6 to 7 kilometers thick. The extra buoyancy of the continental crust causes it to float higher in the mantle, and this is what accounts for the difference in level of the two principal kinds of Earth's surface.
Did you hear that?
The extra in the mantle in level This is what accounts for the difference in level of the two principal kinds of Earth's surface.
Let's hear that again.
This is what accounts for the difference in level of the two principal kinds of Earth's surface.
There you have it, folks. I mean, how can a ball without the Earth's crust, tectonic plates, and earthquakes become a single flat plane? There it is. You also heard it from the video. And Alright, this is a really quick observational experiment. This is a globe you're probably familiarized with. It has its textures on the mountains and everything. And I have printed out the USGS documentation here, where if the sublift did not take place, the relentless force of erosion would reduce the Earth's landscape to a single flat plane. Now let's look at this again. If the mountains here, if the tectonic plates stop pushing up, these mountains would actually have this stop, this picture here, the uplifting force, and should really not become a single flat plane, but instead a solid, smooth ball of water. And it doesn't say that. So this is actually a ball that I got from Walmart, Batman vs Superman, cost me $1, pretty cool. And here is the ball, the blue sphere. If the tectonic plates on a ball were actually to stop working, should actually look like this, but instead it says it's a flat plane. Now I even went ahead and I printed out another, not another, but I got another ball, and I put to perspective that if this whole entire uplifting force stopped working on a ball, because on a ball in the heliocentric model, the core is pushing in all directions. So if this uplifting force in all directions would have stopped completely, it should really look like a deflated, more like a disc, but this doesn't come out to a completely two-sided disc, because it'll be the front and the back, of course, of the ball. But another way would be the disc, a CD. It'll be a two-sided disc, really, because if the ball, this uplifting force stops, this ball would just come together and create one two-sided disc, or maybe like a CD, something like that. But right here it says it's a flat plane. I can come back here into the NASA document that I've heavily put in all of my videos, the NASA definition of a linear aircraft model, and we can go back to page 36 in the concluding remarks. Is that the aircraft, the matrices for the rigid aircraft of constant mass flying in a stationary atmosphere over a flat, non-rotating Earth. And if you look here, it says the equations are derived from nonlinear 6-degree of freedom equations. That's the movement of aircraft in the air. If you haven't seen my other videos, I have 3 of them, and one of them goes into detail with the attitude indicator, which is the gyro compass. I also have another document from NASA that's been unclassified, aerospace classification. Now when we do a search for the word flat, you'll be surprised of how many times it's in here. It's in here 5 times. Now this is actually a document for a camera on an aircraft, and it says envision a camera system oriented as shown in figure B1. B1 meaning this is where the aircraft is and this is the ground. Now here's with the Cartesian coordinate system, whose XY plane defines the ground plane of a flat Earth. Okay, why would they make a camera that wants to pivot around an aircraft to have it be level with a flat Earth. See, the information is out there, folks. Here's the aircraft and a camera, and even here where G in the line above, this indicates is that the vector from the camera niter point to any ground point on a flat Earth. So this is the aircraft with its 6 degree of freedom equations. This is 6-degree axis, the banking, the rolling, the pitch change, everything in the aircraft in free space, with the camera on the bottom to take pictures of a flat Earth. It's just more and more information put together out there pushes forward the flat Earth model. And I know what the naysayers out there always say is like, oh, that's just baloney. They told us in grade school that we have to make fun of the people that think it's flat. They were caveman. I mean, it gets ridiculous. I mean, they even have the people on the YouTube channel, the Turks or something like that, some kind of news channel on there. They have a little caveman dressed up and says that the ice walls are all the way up to space or something. Those guys are really ignorant anyway. But let's see, we can also go to what the Illinois. I mean, Illinois, the study says Illinois is second flattest state on the mainland. Now again, how can we have flat on a ball? Now here it is. Dobson was right, finding half of the Illinois to be flat by using a formula that broke states into small sections and then analyzed the elevation data in those plots. Illinois beat out North Dakota, Louisiana, and Minnesota for the distinction of being America's second flattest state. Kansas, despite its reputation for hill-less plains, was merely the 7th flattest. West Virginia was the least flat. And right here, Illinois owes its flat land to glaciation, said Richard Berg, interim director of the Illinois State Geological Survey. That's why we have some of the best farmland in the world. It's flat. Okay, now let's go on even further. Kansas is flatter than a pancake. This is a study at usu.edu, GeoGeomorph Kansas HTML. Now, what they did here is they did the same thing. They measured it out and they got all the information, and what they did was also the materials and methods. They actually went and purchased a well-cooked pancake from a local restaurant, the International House of Pancakes. I don't know if any of you have heard of that place, but they do make some pretty darn good pancakes. And what they did was they did a lot of measuring. You can see here from the side, the figure 2 pancake cross-section surface being digitized. They digitized the pancake and found that Kansas, through that, was flatter than a pancake. Now, I made this diagram a little bit bigger because it's pretty small there. You can see that here's the pancake, the digitization, sorry about that. Here it is, digitized pancake, and what they did with Kansas. So it's flat. Let's see. And we can just go on and on with this, and I know the naysayers are still out there saying, oh, that's silly. We were taught as a toddler to make fun of flat earthers because we have science. Okay, well, let's just keep on going. We can go to something I wanted to bring up, something I'm done with, but I have to go back because people just keep on being annoying. And you know what? Might as well just go to the website. Alright, the honeymoon packages. Here we are. There it is, Hawaii. And over here we have the island of Maui. This is Hawaii Beach. On the beach, you're pretty much a few paces from the ocean there. And here is the island of Maui, and there is the other one. It's Kaulave. I forget how to pronounce that. Kaulave. Now we can right click and go to save as, and it says the Maui Sunset Romance. And we're going to plot this out, but already I have made a diagram for it. Kaho'olawe elevation is 1,483 feet, which is this island right here. They're on the beach here, looking at the island of Maui over here. Kaho'olawe is right there, so it's an elevation of 1,483 feet from Hawaii Beach, and it's a total of 46.36 miles. Point A to point B is 74.61 kilometers, or 46.36 miles. Now, with the spherical trigonometry of a sphere of 24,901 miles in circumference, at 46.36 miles is a 1,433.25 foot drop of curvature. Now, people are telling me that my math on my curve chart is not correct, and it actually is. I can actually come in here and put in any number. For instance, let's say it's 1,000. I know it's down there, but you can see that 1,000 here, 128, 128, 1,000 here, 128, 128. The system works. The equation on the curve chart is 100%, but people keep on telling me that it's wrong. So what we're going to do here is we're going to go back and look at the miles. 46.36. 46.36. That is 1,433 feet, and this is the decimal point in miles. Okay, now let's go back and bring up AutoCAD, and we're going to go back and make sure they haven't changed the radius yet. So it's 3959 miles for the Earth's radius. Here we are, and then here's the map. And the elevation. And from Wikipedia and Google, 1,483 feet. Now that our data is pretty accurate, we're going to start plotting this thing. So making a radius of 3959. Going to start plotting this thing. And if you've never used this program before, it is AutoCAD Civil 3D 2016. And we're going to do the plotting of a curvature drop on top of a ball and looking out towards that ocean. Basically, the people will be looking out in that direction. Okay? If you've never seen any of my videos before and are new, you probably know this already. But there it is. We're going to zoom in a little bit. Those people are looking in this direction, 46 miles, 0.36. And you can see that's very, very small. And we're going to drop it to the curve. Okay. And we're going to get a linear dimension. Just to verify that there it is. 0.2714, and my Excel sheet and chart say it's 0.2714. It's correct. Okay. And it works. Just learn how to make the Excel chart. Now, here is the other factors that come in here. People like to say that, well, you didn't take account the elevation of the viewer and then the island. Well, look at the viewers. They're only a few steps away from the ocean, so I can just walk down there a few paces, be in the water, and that mountain range is not, I mean, that island is not going to disappear. You just walk down there and it's not going to make any difference. So 1,483 feet, I have to convert that to miles. Get my calculator here. .483 divided by 5280, it's 0.28087. Okay, that represents the top of the mountain. That represents the elevation, 1483. And we're actually going to make a 6-foot man stand at the end. And that is 0.00136. Well, it's 1136. Sorry about that. That's 6 foot. That represents a person standing 6 foot tall. This is going to be the line of sight. To the tip of the mountain. I'm going to change the color here. Now that yellow line represents the line of sight and the blue is the water. So here we have the guy or the lady looking in that direction, and let's see how far it is before it hits the water. And you can see that there's a lot of curvature in the way, hiding look at that. How can anybody see that entire mountain range with that whole bulge of water in the way? And if you look at the math, the foot drop is 1,433 and the elevation is 1,483. So that island back there does not look like it's 50 feet tall. It looks like it's the whole entire thing. You can see here you have a few up and down here on the mountain, so 50 feet can be like up here where my mouse is. But sitting here and telling me, or telling yourself, that you're looking at this island from this far of a distance and that it's a mirage, it's kind of crazy, because we have too much of this going on now. And it's not a circumstance now, because circumstances have completely now been thrown out the window. It comes way too often to be a hologram, a mirage. Now, we go back and look at the round Earth, just look at how much is in the way. Look at that. That much. There's hundreds and hundreds of feet of curvature of the water in the way of this island, and then it's only 50 feet. .0094. It's 50 feet. There it is. 0094. 0094 times 5280, which is a mile. That's 49 feet. That's not 50 feet, folks. That's the entire island. And I guess that's it for today. I'll leave the comments open. I'll have, everything. I'll leave everybody to comment, see if they come up with something different. Again, you can do this whole diagram at home. I supplied already the math for it. And have a good day.
Check this out. Astronaut Scott Kelly tweeted this photo to all of us here, remaining on Terra Firma on the Earth, 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 remaining on Terra Firma on the Earth. Kelly's been in space for nearly a year and says this is one of the best sunrises he's seen. And, he's seen a lot. The International Space Station circles the Earth 16 times a day. That means 16 sunrises and sunsets every day. In his only one-on-one interview with Fox News, Scott Kelly told our Elizabeth Pran how he feels about the last week he'll spend on the International Space Station.
Yeah.